Good morning, guys. Okay, so starting out the day again with some triangle congruence review. So let's take a look at proving these two triangles are congruent so that we can prove, or no, that's what we want to prove, just those two triangles are congruent. So let's go ahead and do that. I'll pause, you guys try out this proof, see if you can come up with anything, and then come back to check the answer. Go ahead and pause now. Okay, so here's the proof that I got. Now keep in mind, your proof, these parts could be in a different order there. They don't have to be in the exact same order that I have them in. But let's talk about how I did the proof. Just go over it real quick and so you guys can get a little bit of understanding from it. So first off, I looked at my givens. I was given C is the midpoint of BD. So if this is a midpoint there, then that means it cuts BD into two equal parts. That's where I got those green lines. So that shows those two parts are congruent by the definition of midpoint. So there's my first piece. Keep going with my givens. Angle D is congruent to angle B. So I got these two angles here. Those are just given, they're congruent, so I put those in my proof. And then finally, when I have those two lines crossing, I have those vertical angles that form. So I mark those in blue there. Those vertical angles are congruent by definition of, or by the vertical angles theorem. And so now I've just listed those things here in my proof, my two givens, that definition of midpoint piece, the vertical angles. And then if you look, those three pieces of information show angle, side, angle, so that's why the two triangles are congruent. All right, so there's my proof. If you need to pause, check it, go ahead and pause now. Okay, so let's take a look at our goals for today. So what we're going to do today is we're going to do something called solving right triangles. So we're going to take all those skills that we learned about right triangle trig and we're going to put them into solving all the missing pieces of any right triangle. And then we're also going to take a look at draw a picture problems. It's what I call word problems, because really that's all a word problem is. It's one where you have to draw your own picture. So let's jump in and take a look at this first topic, solving right triangles. All right, so for this first one, what I want you guys to do is go ahead and copy that down into your notes. If you want to, take a minute, get that copy down, pause the video. All right, so let's take a look at how I would approach this. So this problem, if you notice, wants us to find the value of each missing part of the right triangle. Here I've listed the three parts as variables, x, y, and z. So basically all we need to do here is find all three of these missing parts using the information that we're given, this 30 degree and that 13. We want to use just those two pieces for each one of these, because that way if we mess up, say when we were finding x, it's not going to affect our answer for y or z. So let's take a look at how we would do this. So first off, what we're going to do is we want to look at, let's just go alphabetical order. It doesn't really matter, but let's go alphabetical to keep it easy. So first one we want to find is x. Now, if you look, this is a right triangle. So if it's a right triangle, these two angles here have to add up to 90 degrees because that corollary of the triangle sum theorem. So if these two have to add up to 90 degrees, that just means for x, let's make a little, so this is solving for x here. We're going to say x plus 30 has to equal 90. And then if we solve for x, all we got to do is subtract 30 from both sides. We're going to get x is equal to 60 degrees. So that's our first one. X has to equal 60. That one was pretty easy. So let's write that in here, that this is 60 degrees. All right, cool. So the next one, let's take a look at y now. So let's make a little area to solve for y. So solving for y, what we're doing now is we need to look at some right triangle trig, because we don't have any easier way to figure out what the value of y is. So we're going to use right triangle trig. So what we need to do is we're going to use that concept, those 4 steps we always use for right triangle trig. First, identify the angle. So in this case, the only angle that we were given was this 30. Now we could use 60, but if we would have messed up with that 60, say we just subtracted wrong somehow, then that's going to mess up our answer for y if we use it. So I always try to use the one that was already given to me because I know that that number is correct. So we're going to use that 30, that's our angle. And then we're going to use the side we were given. In this case, we were given that 13, so that is opposite of that 30. And then we're going to use our y because that's the value we want to find. So this is going to be our adjacent. So we did the first two steps. We found the angle. We identified the sides. Step 3 is to pick our trig function. So let's write this up here real quick. So toa. Remember, guys, if you broke a toa, you got a SOHCAHTOA. So we have the opposite and adjacent. So we're going to come to SOHCAHTOA here. Opposite and adjacent. That's going to be the tangent function. So let's write our equation now. Step 4, set up and solve. Tangent of our angle is equal to the opposite, 13, over the adjacent, y. So now solving this equation, remember that little rule I told you guys, if the variable's in the bottom, then you just divide by the trig function. So we're going to say y is equal to 13 divided by the tangent of 30. So now from there, all we need to do is put that in our calculators and solve. So let's go ahead and put that in. We're going to say 13 divided by tangent of 30. Close those parentheses, hit enter. So that's what we get. 22.516666049. But again, we're just going to round to that third decimal place. So we're going to do 22.517 because that 6 causes the 7 to round up. So 22.517. And we'll say that's just units since we don't know what exact units it is. All right, so that's y, 22.517. Let's write that in there. 22.517. Okay, so we got one more problem to do, and that is to find z. So z, we're going to go the same exact approach we did for y. Follow those 4 steps that you always follow for right triangle trig. Identify the angle. So again, we're going to use the 30. We have to use the 30 because that's the angle that's given to us. Then what we're going to do is step 2, identify the sides. So we got this side, that 13. So that again is opposite of the 30. And then z, that's going to be the hypotenuse. So we have opposite and hypotenuse. And again, we don't want to use y because we solved for that. So that means if we made a mistake, that would mess up our answer for z if we use that 22.517. We only want to use those numbers given. So we have the opposite and the hypotenuse. So we're going to come over here, look at our trig functions that we have. Which one's opposite and hypotenuse? Well, that's the sine function. What we're going to say now is that the sine of our angle is equal to the opposite, 13, over the hypotenuse, z. From here, all we're going to do is solve for z. So to solve for z, remember if the variable's on the bottom, you just divide by the trig function. So we got z is equal to 13 divided by the sine of 30. From here, all we have to do is put that in our calculators and solve. So let's go ahead and put that in our calculator. We're going to say 13 divided by the sine of 30. Enter. Hey, check that out. That's actually a whole number. That's z is equal to 26 units. So our hypotenuse is 26. All right, and that's it. So all solving a triangle is it's taking, instead of just having to solve for one side or one angle, we're solving for all the missing pieces given 2 of those parts. But that's it. So if you need to, pause to continue to get these notes down if you missed anything. If not, let's go ahead and look at one more example. Okay, so go ahead and get this example copied down into your notes. If you need to, pause the video now. Okay, so let's take a look at this one. Again, all we're doing is we're finding the value of each missing variable. So let's go alphabetical order again just to make it easy on ourselves. Let's take a look at x first. So if we look at x in this one, last problem, all we did was we subtracted whatever the value of the other angle is from 90. But we don't have the other angle in here. So what we have to do is remember, how can we find the measure of an angle using right triangle trig. And if you remember, you can use the inverse function. So all we're going to do is we want to use right triangle trig because we have no other good way to find x. So let's look at our SOHCAHTOA here. Let's get that down before we even start. Okay, so back to x here. Remember, step 1, identify the angle. Well, x is our angle. Step 2, identify the sides. So 14 is opposite of x, and 28 is the hypotenuse because the right angle is pointing at. And it's also the longest side. So we have opposite and hypotenuse. Come up to your trig functions. That's going to be the sine. So to solve for x, let's do a little work here. We're going to say that the sine of, and in this case, x is our angle, so that's what goes with the trig function. Angle always goes with the trig function. Is equal to opposite 14 over hypotenuse 28. So from here, all we have to do is we need to solve for x. So you guys remember from yesterday's class, to solve for this angle, all we're going to do is take the inverse sine of that fraction. So we're going to say the inverse sine of 14 over 28. So that's what we have there. So that now has just become a calculator problem. Now keep in mind here, with a problem like this, some calculators, yours says inverse sine like I wrote, but like mine says here, it doesn't have that to the -1, it has an a sign. And all that means is arc sine. It's just another way to say inverse. So if you ever see that this symbol, arc sine, that means the same thing as inverse sine. Just another way to write it. But anyways, back to the problem here. We're going to do inverse sine of 14 divided by 28. Oops. 14 divided by 28. Hit enter. Hey, look at that. X is equal to 30 degrees. So there we go. That's 30. Now, that was x. Let's take a look now at y. Actually, let's put that 30 in so that we know. That's 30 degrees. Okay, so y. Now, we may have made a mistake for x, so we don't want to do 90 minus 30 to get what y is. But what we want to do is we want to use those numbers that we were given. So the numbers we were given were these two sides. So we're going to follow our right triangle trig steps again. Y is our angle, so step 1, identify the angle, we did that. Step 2, identify your sides. 14, well that's going to be adjacent. And 28, that's going to be the hypotenuse. So what we want to do now for y, step 1, identify the angle. Step 2, identify sides. Step 3, pick your trig function. So we have adjacent and hypotenuse. So we're going to come up here. There we go. Cosine is our adjacent and hypotenuse. So we're going to say the cosine of our angle, y, is equal to 14 adjacent over 28 hypotenuse. From here again, just like we did for x, we're going to take the inverse cosine. So y is equal to the inverse cosine of 14 over 28. Now, if we did the first one right, y should equal 60. But let's check. Let's put in our calculators and see if we get 60. So I'm going to press second cosine. That does our inverse cosine of 14 divided by 28. Enter. And look at that. It does, in fact, equal 60. So now we got a y value of 60 degrees. So if you ever have to find both angles, you can kind of check yourself to make sure you did them both right and see, do they add up to 90? 60 plus 30? Yep, that adds up to 90, so we're good. All right, so we got one more piece here. We got to find that side z. Now, with z, what we want to do is we don't want to use these two angles that we got just in case we made a mistake. We only want to use the two numbers that were actually given to us, this 14 and 28. So to find z, the only way you can do that given two sides of a right triangle, can't use right triangle trig because you need an angle at least to do right triangle trig. So using those two sides, what we can use is that Pythagorean theorem, that a squared plus b squared equals c squared. So remember, c has to be 28. And then the other two, a and b, they can kind of be interchanged. So we'll say that B is the 14 feet and A is Z. So we're going to say A squared, or Z squared in this case, plus B squared, which is 14 squared, is equal to C squared, which is 28 squared. Now let's simplify these. So Z squared can't do anything with. 14 squared is 196, and 28 squared, I believe, is 784. Check me on that one though. Okay, so now from here, all we gotta do is solve this equation for Z. So we wanna get Z by itself. So first, I gotta get rid of this plus 196 by subtracting it. Simplify both sides. Get Z squared there. 784 minus 196, that's gonna give you 588, I believe. Okay, and last step here, we want to get what Z squared equals, or what Z equals, so we have to take the square root of both sides to get Z by itself. So then we're going to get Z is equal to the square root of 588. And from there, we need to put that into our calculators and see what we get. So, square root of 588. And generally, guys, the square root button is going to be with that x squared button. It'll be like if you press second and then the x squared. So then 588 equals 24.249. But I know, and if you have the yellow calculators, which most of you probably do, you should actually get the answer 14 times the square root of 3. So that's the answer you should get. And you can go ahead and just leave it in that form there. So that means Z is equal to 14 times the square root of 3. And then remember, this is in units of, and they actually gave us the units here, so we're going to say feet. Feet. All right, so there's two examples of how to solve a right triangle. So there's only really 3 different methods you can use. You can use regular right triangle trig. You can use inverse right triangle trig. You can use the corollary to triangle sum theorem. So basically they add up to 90. Triangle sum theorem. Or you can use the Pythagorean theorem. Any of these 4 could come up in this problem. But that's it. If you know those 4 things, you can solve in any right triangle. Okay, so what I want you guys to do now is, if you don't got this, finish getting this. Pause if you need to. But then I want you guys to try any single one of these problems. I don't care which one you do. I just want you to try one of them. So do one of these examples in your notes, and then find somebody else that did that problem as well and compare your answers with them. So go ahead and pause now and try one of those problems. I'd say maybe 5 minutes. Okay, so here's my work for those 3. Hopefully you guys got those same 3 answers for each of those. Keep in mind, all I did was I used one of those 4 properties. I used right triangle trig, or I used the inverse of right triangle trig, which is basically the same thing, or I used the Pythagorean theorem, or that corollary that says all the angles add up to 90. If you can do any of those 4, you basically got this down. All right, guys, so our next topic, I'll give you guys, I would pause here and make sure you check those answers. Everything looks good to you guys. But our next topic is going to be draw a picture problems. So we're going to end this video and come to that topic next. But before we do that, sorry I forgot, I want you guys to do one quick question. I want everyone to try this one. A quick understanding check. Find the value of each of these variables. So try this one out and then come back to check your answers. Go ahead and pause now. Okay guys, so there's my work there. For x, because I had 2 of the sides, I used the Pythagorean theorem to solve for that one. Then for y, because I had 2 sides and no other angles, I used inverse RTT, right triangle trig. And then the same thing for z, because I had 2 sides and no other angles, I used inverse right triangle trig. Okay, so those are my 3 problems. Now we're officially done practicing these. You guys should have a worksheet that has a bunch of these problems on, so if you want more practice, absolutely try those, and the answer key will be posted on the website if you want to check that out. But we're going to go ahead and transition now to our next topic. So go ahead, pause this video if you want to get the rest of that if you didn't get it all. If not, feel free to just wait for the next video to load.